Okay, this is the second video on combining like terms. In this video, we're going to practice combining like terms and also how to use or how to combine like terms when using the distributive property. You need to make sure that you have your homework packet with you, as well as the combining like terms handout that is printed on the blue sheet. It looks similar to what you see. So let's go ahead and start with a handout. So in our first video, we went over some of the terms or the vocabulary for the different parts of algebraic expressions. And let's just review. So if you look right here, 3x squared, this arrow, this top arrow is pointing to the 3. On this expression, or in this term, what does the 3 represent, or what is it called? It is called the coefficient. It is the number. It's telling you how many groups of x squared we need. Then the lower left-hand arrow is pointing to the actual 3x squared, and that is called the term. Remember, like terms have to have the same variable to the same power. Okay, this red arrow is pointing to this x. This x is a variable. And this one is pointing to the 2. When you have just a number, it is called a constant. And then this top right arrow is pointing to the 4, or probably the negative 4, and again, that is called the coefficient. So as you can see, the coefficients are very important when combining like terms. You need to make sure you know what the coefficient is, and make sure you have your name on this. The bottom part of our handout, let's go ahead and fill it in. Like terms have the same, and we learned this from the first video, they have the same variable. So make sure you're filling this in. And the same power, or exponent. Okay, so when you're getting ready to combine like terms, there is a to-do list. The first thing you need to do is add all invisible positive signs. So look at our blender, look at all our different terms. Anything that does not have a negative sign means that it is positive and that the sign is invisible. Our 2m, this is a positive 2m. The constant 2, that's a positive 2. This one is a positive 8. A positive n squared. The 6 is negative. Over here, the term mn is a positive. And the term down here, the m, is also positive. Then you need to add any invisible 1 coefficients. So coming through, when I have this n squared, there is no coefficient, but there is one of these terms. That's the invisible 1. Same thing for the mn. There is an invisible 1 coefficient. And the m, there is an invisible 1 coefficient. Then to combine, you would color like terms with matching patterns and colors. You could do the colors, the patterns. As you saw from the first video, I do shapes. I'll circle one, like here. I'll circle the 2m. And all of the other m terms, I will also circle. I will use the same shape. Down here, here's another m. Then for my constants, I maybe will put a square around them. So all of my constants, I will put squares around them. Here I have an n squared. Maybe I will just kind of do a triangle, or what looks like a triangle. Do I have any other n squareds? No. Here I have an n, so I'll put a little wavy line underneath there. Are there any other n terms? No. Remember, this n squared and this n term are not the same. Yes, they have the same variable, but they're not to the same power. Then over here I have an mn term, and here's another mn term. This one has 2 variables, the m and the n, so they are alike. Okay, so we did this one. And then, of course, on this sheet, color, doodle, and embellish the key ideas so that you remember them. Okay, so there is an actual way to write your expressions once you've simplified them and combined the like terms. And this is called standard form. To write your simplified expressions in standard form, you're going to order the terms so that the exponent, or the power, decreases from left to right. So you start with a larger exponent. If you have something squared or something cubed, that would go first. Constants will always be last, and your variables should be in alphabetical order. Now, the standard form is really important when you get into algebra, but for now, I'm not really worried that you have it in the correct form. We need to really focus on being able to combine like terms. That's our main focus. But it's good to know what the standard form is. So let's go ahead and try these two examples on the left side. Okay, I'm going to start with my first term and circle it 3y's. And I'm going to go through and circle all of my y terms, and I'm going to make sure I include the sign in front of it. So here's a negative 6y. Okay, this 12xy, there is a y, but it also has the x variable. And that's not what we're looking for. We want the only the terms that have y's. And that's going to be it. So I have a positive 3 and a negative 6. I combine the coefficients and it makes a negative 3y. Okay, then I'm going to put a square around my negative x. Remember, this has that invisible 1, so it's a negative 1x. Do we have any other x terms? No. xy is not the same as the x. So it's just negative x. My next term is the constant. It's a negative 1. Do we have any other constants? Yes, we have a positive 4. Make sure you're including the sign. When you combine them, signs are different, subtract, we get a positive 3. Then we have a 12xy. Any other xy's? Yes. We have an xy down here with the invisible 1 coefficient. So 12 plus 1 makes 13xy. So we've gone from 1, 2, 3, 4, 5, 6, 7 terms down to 4 terms. We've simplified it to 4 terms. So I'd like for you to go ahead and pause the video and work problem 2, combine your like terms. When you're done, come back and check your answer. Okay, let's see how you did. All right, start off with the ABs. 4 ABs and negative 1 AB would make 3 ABs. The next term is negative a squared, and we also have a positive a squared. They're both just 1, so they cancel each other out. So there are 0 a squareds, which we don't write that. We just leave the a squareds off. Then we have a positive 3a. That is the only a term, so we bring it down, positive 3a. And then our b terms. We have a negative 1b, that invisible 1 coefficient, and a negative 2b, so that makes negative 3b's. If you wanted to write it in standard form, it would be 3a plus 3ab minus 3b. But again, what we're really focusing on is the combining of the like terms. Okay, let's go ahead and go to our packet, page 5. We're going to do some practice problems. Numbers 1 through 6, you're just going to simplify the expressions by combining like terms. So let's go ahead and work number 5. Okay, the first term is an x. I'm going to circle it. Make sure that you are showing like terms by using the same shape or color if you want to use a highlighted color. All of my x terms I'm going to circle. There are no other x terms, so I have 1x, which is just x. My next term is a y, positive 3y. I'm going to use a square. Any other y terms? Yes, a positive 5y. We're going to add the coefficients. A positive 3 plus a positive 5 make positive 8y's. And then lastly, we have our constant of a positive 12. There are no other constants. So our simplified expression is x plus 8y plus 12. That's how you're going to do 1 through 6, so you'll finish those on your own for homework. Now let's take a look at numbers 13 through 16. These are a little bit different. Does this look familiar? It should. It's what we've already done. It's the distributing property. Okay. To simplify these expressions, we need to get rid of the parentheses. Okay. This is saying 3 groups of x plus 2. We want to get rid of the groups and just come up with a total. So sometimes you're going to have to use the distributive property first, and it tells you that in the directions. First, use the distributive property, and then you combine the like terms. So this is a two-step problem. So let's work number 13. We want to get rid of the parentheses, so we're going to distribute the three groups to each term inside the parentheses by using multiplication. So this is a 1x, so we multiply 3 times the 1, and we get 3x's. Circle the second term in the parentheses, it's a positive 2. So we're going to distribute the positive 3, the 3 with multiplication. 3 times 2 is a positive 6. Now, are we going to distribute this 3 over here to this 5x? No. This plus 5x is not inside the parentheses. So it's not part of the group. We do not distribute the 3 to it. We just bring it down, plus 5x. Once you've distributed and you've gotten rid of the parentheses, then you combine your like terms. Do what we were doing over here for 1 through 6. My first term is 3x. I'll put a square around it, and I'll square all of my other x terms. Here's a 5x, so 3x plus 5x makes 8x's. And then I have the constant of a positive 6. There are no other constants, so I just bring it down. So my final answer, my final simplified expression is 8x plus 6. And look at the bottom. For numbers 23 and 24, we're going to write an expression to find the perimeter of the polygons. Perimeter means the distance around the polygon. To find the perimeter, you add up all the side lengths. Now these are a little bit different because we're used to lengths being in inches or in yards. These are algebraic expressions. The concept is the same. We add up all of the sides. So I'm going to take my first side of 2x plus 7, and I'm going to write a big old expression. This is my first side. To that, I'm going to add the next side, which is 3x plus 1. And then finally, I will add the third side, which is just x. This is the perimeter of the polygon. It's awfully long, so we need to simplify it, make it easier to work with by combining like terms. So I'll start with all of my x terms. I'll circle them. There's 2 x's. Here's positive 3x, and here is a positive 1x. 2 plus 3 is 5, plus 1, because that's the invisible 1, makes 6 x's. My next term is a constant, a positive 7, so I'll square all of my constants. Positive 7 plus 1 makes an 8. So the perimeter of this polygon is 6x plus 8. Your homework assignment is to complete this page in your packet.